This is going to be a quick demo of how to build for Azure using Nitric, GitHub Actions, and Copilot. For this demo, we'll be building a cloud application that's the beginnings of an e-commerce site. We'll be keeping the code pretty straightforward, but we'll have two services, one for handling orders and another one that handles generating invoice PDFs for those orders. There'll be a topic that binds those two things together and a bucket or a blob store to contain the PDF files. To get this all running in the cloud, we'll need a number of resources, including a resource group, two Azure container apps, orders and invoices, a container registry for the Docker images for those containers, and a container app environment to run them in. We also need an event grid topic to bind them together, and a storage container inside a storage account for storing the PDF documents that we generate. In addition to that, we're going to need to set up all of the IAM rules that secure these resources and allow them to communicate with the other resources that they need access to and nothing else. I'll be building this example application in real time using Nitric, but I'm also going to show you an equivalent application built using more traditional tools like Terraform to give a bit of comparison of how Nitric is different. I'll start by using the Nitric new command to scaffold a new project in TypeScript. Next, I'll install dependencies and I'll move into that project with VS Code. Nitric projects look a lot like any other project in the chosen language, except with the addition of this nitric.yaml file. This file tells Nitric the name of your project, as well as where to go looking for all of the entry points to your application. In this case, by default, we use a folder called functions and any file in there that ends in .ts. The template comes with a hello world example, but I'm just going to delete that so we can start from scratch. We'll start by creating a file called orders.ts, and this is where we're going to create our orders service to accept incoming orders and publish them on the topic. Since I want the orders service to expose an API, I'll start by bringing in the API resource from Nitric. I can use this to define a new API called orders and store it in the variable orders API here. Before we start developing the API, we know we also want a topic that binds the orders service to the invoices service so we can send events between the two. So this is where Nitric is quite different from traditional infrastructure as code approaches. At this point in Terraform or another product like that, I'd be switching out of context into another language like HCL to start defining resources like topics, or I need to start coding assuming they exist and figure out their details later. By comparison with Nitric, I can include a topic resource right here in my code, and I can create the order updates topic in line in my application, as well as request the publishing access that I need to be able to send events to that topic. Now that we have the topic, we can start building the orders API. I want to start with a post method for /order that accepts new incoming orders. Now, in a realistic scenario, we would do things like data validation and error handling here, as well as what I'm showing. But to keep things simple, we're simply going to accept whatever data that we get sent to this orders API, and we'll forward it to the invoices service using this topic via the publish method on the topic. Now that I have my API route and I have my topic accepting incoming events, I can start to create the subscriber. I'll do that by going back to my functions folder and creating a new file called invoices. This will be my invoices service. At this point, I might be thinking about my infrastructure as code again, figuring out a way to bind my topics, incoming events, and send them through to this invoices handler. In this case though, with Nitric, I can simply re-reference that topic resource that I defined earlier using its name. In this case, we don't want to ask for permission to publish. Instead, we want to call the subscribe method. The subscribe method lets me process incoming events with a function that will be called on every new event sent to the topic. In our case, we want to pull out the payload event, which represents the order. We want to forward these order values through to another service that externally generates PDFs and gives us back a file that we can then store in our container. For that piece, I'll just pull in a bit of code we've prepared earlier, so you don't need to watch me write it. So at this point, you can see I'm calling an external API that's going to generate invoices and give me a response. And then I've got an invoice PDF that I want to store somewhere. I'll just add these missing variables for the invoice API URL and API key. And next we want to create a bucket where we can store this PDF file. Again, Nitric can help us out. I'll call it the invoices bucket. And I'll say in this case that I want access to write to this bucket. We also support other access like deleting and reading, but writing's all I need in this case. Now that I have that bucket and the ability to write to it, I can start writing these PDF files. In this case, I'm going to create a file named after the order number for each incoming order.pdf, and then we're going to write the invoice PDF to that bucket. With that, I've got everything I need to deploy this application to the cloud and start testing it. Before I do that though, I'll do a quick comparison of what this would look like if I had built it with Terraform. So you can see here we've written about 26 lines and 9 lines in our orders service. In total less than 40 lines of code, both for the application and all of the resources that need to be deployed to support that application, along with things like access and IAM. By comparison, if we open the same application written with Terraform, you'll see that the application code looks quite similar. We have an orders service and an invoices service, and the code for each of those looks pretty similar to what we saw before, except in here we're using the event grid publisher client directly, and we're developing our APIs using Express.js. Additionally, you'll see other code in here helping us locate our resources in Terraform, such as finding the topic and the region that it's hosted in, and then setting up the clients that we need to access that topic. It's a similar case for the invoices service, with the source for that looking very similar once again. We've got a handle orders route here acting as a webhook for incoming order events from our topic. Again, you'll see a number of extra lines of code helping us locate and validate that we're connecting to the correct resources in Azure. And then finally, inline in our application, you'll see similar code using these Azure clients to store the PDFs in our blob store. The area where this application looks quite different though is when we start to dig into the deployment of the resources themselves. Unlike in Nitric, where the application code also handles deployment, in this case we need a Terraform file. We've got our main.tf, which is in the area of 125 lines and deploys all sorts of different resources to Azure, such as our resource group, storage account, the storage container, container registry, and so on. All of these same resources are deployed in the Nitric application without this explicit definition. On top of that, we've also created a Terraform module for our container apps, since we're deploying 2 container apps with relatively similar configuration. Here we've set up a script that builds Docker images and deploys them. Again, this is something that Nitric takes care of for you, automatically containerizing application code and deploying it to the cloud. In this case, we've saved another 70 or so lines of code. The thing to note about this Terraform code is there's no clear relationship between the code that depends on these resources and the deployment scripts that push them into the cloud. The reality is that these 2 aspects of our application are highly dependent on one another. If any of these resources are missing or misconfigured, the application as a whole ceases to function. This is why Nitric aims to embrace this coupling between application infrastructure and the application code itself, while reducing the burden on the developers to create that infrastructure. At this point, I'm ready to deploy the application to the cloud, and that's something else that Nitric can help with. I'll start by creating a new stack, which represents a deployment target for our application. I'll choose Azure as the provider for my target, and next I get to choose the region. In this case, I'll choose ECUS. There are a couple other details to fill out, and I'll just put them in now. At this point, I'm ready to push to the cloud, which is something I can do locally, or just as easily achieve with tools like GitHub Actions. For a first deployment, I'll start by doing it locally with the Nitric up command. Now if I switch across to my Azure account, I can see the new resource group that's been deployed for this demo bookshop application, and over 10 different resources deployed in the cloud. We did all that in less than 10 minutes with a bit of help from GitHub Copilot and Nitric. The last thing we'll want to do is create a GitHub Actions workflow so that any future changes we make to this application will be automatically deployed to Azure. I'll start with this suggestion from Copilot and adjust it for a Nitric deployment. With that, I've got everything I need for a continuous delivery into Azure so that any changes that I make in my code automatically get pushed through to production without ever having to write any Terraform or infrastructure as code. If you want to learn any more about Nitric, come and visit us at nitric.io or come and chat to us on Discord. Cheers.